So this is 6.2b, and we're on page 508, and this is part B. We're just going to do one of these, example number 7. And if you remember right, we've done these before where we've had polynomials on top and then a monomial, or just one term on the bottom. And I had told you that to me, the easiest way to do this is just separate those two and write your denominator twice or under each term, depending on how many terms you have. And then I can just look at this part, and then I can look at this part and do what's necessary and just put a minus sign between them. All right, so if I were to look at just this section here, I've got 15 divided by 5 is 3. And really what I'm going to do is make this into a fraction, make both of these into a fraction, just in case there are some numbers that go in the bottom. All right, so then I do x to the 2/3 over x to the 1/3, common denominators. I divide exponents. Remember, you subtract. So that's 2 minus 1, which gives me an x to the 1/3. And then when I look at the b, or the y's, I have a 1/3 minus 1/3, which is 0. So that makes our y's turn into 1, so they go away. Because we get, actually, what we get is y to the 1/3 minus 1/3, which is y to the 0, and anything to the 0 power we talked about being 1, so we don't even have to put it on there. Okay, so that's all we have when we do this fraction. So let's go to the other one. So we have 20 over 5, which is 4. We have x to the 4/3, x to the 1/3, so we're subtracting them. They have to have common denominators, but we can subtract 4 minus 1 is 3. So we have x to the 3/3. And if you remember, 3/3 is the same as 1, x to the 1 power, so we don't even need an exponent there. And then we've got x to the 2/3 over y to the 1/3. 2 minus 1 is 1, so we have y to the 1/3. And in this case, there is nothing down here in the denominator on either one of these, so we end up with 3x to the 1/3 minus 4xy to the 1/3 for our answer. So not too difficult. I think that's probably why they just gave you one example, is they're not too bad. But in C, we're going to do factoring expressions containing rational exponents. Okay, so this is example 8, bottom of page 508. What we're doing is we are factoring this out of this. So I rewrote this part here so we could actually do the work here. So what does that mean, factoring that from that? It's basically the same thing as saying factor a 3 out of 3x squared plus 9x minus 6. So it's saying factor a 3 out. In order to do that with this one here, we would say a 3x squared plus 3x minus 2. So there we did it. We factored a 3 out of that, and we wrote what was left over. So if we take this and we multiply these back in for each one of these terms, we'll get our original here. So that's what we're doing here, only it's a lot more complicated. So if we follow the rules of whatever we factor out, if we were to multiply this 3 times this, we get the original back. If we keep that in mind, we can probably get through here without too much pain, although there will be some pain. Okay, so what we're going to do is we are automatically going to take a 3x minus 2 to the 1/3 out. So we're pulling it out of here. And the key thing right now is we're writing what is left on the inside. So if we pull out a 3 from the 12, we're left with a 4. 3 divided into 12 is 4. And that's what we're doing. When we factor something out, how many times does that something go into what we're factoring out. So how many times does 3 go into 12? 4 times. Okay, that's the easy part. Let's jump over to factoring 3 out of this one. That is 3 times. Okay, so another easy part. Now we have to figure out how many times this goes into this. So x minus 2 to the 1/3, that should be a 1/3. It looks more like a 1/2, doesn't it? Let's make it an official 1/3 here, because that gets me into trouble is when I write the problems wrong. In fact, I did write the problem wrong, didn't I? This one is a 4. Did I make any other mistakes in here? X minus 2, 4/3, x minus 2, 1/3. Okay, now we're okay. So now I'm trying to figure out how many times does x minus 2 to the 1/3 go into x minus 2 to the 4/3. All I have to do here, we're dividing, right? How many times does this go into this? We're dividing. When you're dividing, you take the numerators and subtract them. 4 minus 1 is 3. So this ends up being x minus 2 to the 3/3 power, 4 minus 1 to the 3/3, which 3/3 is the same as 1, right? So we don't even have to show that up here, my little micro eraser. So that's not too terribly bad. Okay, so now let's look at this other one. How many times does x to the 1/3 go into x minus 2 to the 1/3? Well, because the exponents are the same, it goes into it 1 time. So what we get is x minus 2 to the 1/3 minus 1/3. 1 minus 1/3 minus 1/3 is 0. So this is the 0 power. And anything to the 0 power means 1. So that goes away. So we get, for our answer, at least at this point, distribute here. Okay, and this becomes minus 11, so I'm going to erase that and just put the minus 11 in there. And we are done. So following along with what I'm doing may not seem too terribly difficult, but the struggle is keeping track of all the details. That is the hard part, is the details. You make one mistake and it messes everything up. And it not only messes everything up, but it's almost impossible to find the mistake. And I suggest that if you get the wrong answer, just start over again, because it's real hard to find that mistake in there. All right, so this is saying example 9, top of page 509, to factor this as if it were a trinomial. Now there's a trick that you will continue to learn. You probably learned it if you took Algebra 2, or maybe even in elementary algebra, I'm not sure. But anyway, there is a trick here. And the trick being that we take the middle exponent and make it equal to something else. And in this case, let's just make it equal to y. Okay? Doesn't matter what letter you make it equal to, but you pick that middle variable with its exponent and you make it equal to just a letter. So now instead of writing 3x to the 1/3, I'm going to write 3y. And this x says x to the 2/3. So this is actually x to the 1/3 squared, right? So we're going to make that y, and we're going to put the squared on it. Okay? That is a really, really awesome trick to be able to use. So I would suggest doing it. Most books don't tell you to take the middle term and use the variable with its exponent and make it equal to a letter. but this book seems to do that a little bit. All right, so now we can just factor this. And we get that. So now all we have to do is go back up here, and we're going to revert back to, we're going to, instead of x to the 1/3 equals y, we're going to do y equals x to the 1/3. So now wherever we see a y, we're going to put our x back into its place. Okay? Because really, when you're factoring a trinomial, for the most part, you're just dealing with the numbers. See, we've got the -5 and the 2, which gives us the 10. Added gives us the -3. We didn't do anything with the variable in the exponents. So the variable in the exponents make it really, really confusing because they've got fraction as exponents, and it's like, what the heck do I do with these? Well, if we just make the variables something simpler, we can do the math with the numbers and then put the difficult back in there in our final answer. And it just makes things so much easier. Okay, so let's look at example 10 the same way. So I've got 6x to the 2/5, and I've got 11x to the 1/5 minus 10. Okay, so I'm going to make x to the 1/5 equal to y. And this changes it to 6y squared plus 11y minus 10. So now I can go ahead and do the math. So remember, we take the first and last term, multiply them, find two numbers that give us -60. Added give us a positive 11. And those numbers are 15 and 4, positive 15 and -4. So if you remember, we're just going to do this all the way out, just because sometimes you forget over the weeks of doing this, and then we're going to group. We're going to pull a 2 out and a y out and be left with 3y minus 2. And we're going to pull out a 5, and we're going to be left with 3y minus 2, which is 2y plus 5 times 3y minus 2. So now all we have to do is go back up here and notice that y is 1/5, so 2x to the 1/5 plus 5 times 3x to the 1/5 minus 2. And that means that we're done. All right, so this is example number 11, and all we're doing here is combining two expressions. So it's kind of like if we had 3x minus x squared over 2 plus x. And in order to combine these, remember we need common denominators. So we would look and see, well, this is actually over 1, right? What we're missing here that I have over here, I have a 2 plus x. So I'm going to multiply top and bottom by 2 plus x. And that gives me common denominators of 2 plus x. And then I can write the top all over 2 plus x, okay? And then I can factor from there. So we're doing the exact same thing up here, it's just more complicated. So this is a reminder of what we did. So let's go to this one and actually do that one. Get rid of all this junk of my made-up problem. Okay, so what do we have? This is over 1. So what am I missing here over on this side that I have over here? Well, that whole x squared plus 4 to the 1/2. So let's go ahead and multiply top and bottom by x squared plus 4 to the 1/2. X squared plus 4 to the 1/2. Okay, so that is the first step. There's not, now we have common denominators. So we can write this whole thing over 1 fraction of x squared plus 4 to the 1/2 power. So let's put x squared plus 4 to the 1/2 times x squared plus 4 to the 1/2 minus x squared. So now what we need to do is figure out how to simplify this stuff up here. This is really a lot easier than it looks, because what we're doing is we're multiplying these two. We're not doing the FOIL method because we have exponents up here. If we didn't have this 1/2 here or the 1/2 here, we could do the FOIL method to simplify. But this is basically like multiplying well, let's just do it. We've got 1/2 and 1/2. So when you're multiplying something like 3 to the 1/2 times 3 to the 1/2, what do we do here? We add the exponents. That's all we're doing here, is we're adding these exponents here. So we have x squared plus 4, 1/2 plus 1/2 is 1. So really our exponent here is 1, which we don't have to show, minus x squared all over to the 1/2. Okay, so now we can take the parentheses off the x squared plus 4. And notice we're subtracting this x squared, so we can get rid of those. So we end up with just the number 4 in the numerator and that in the denominator. And we're done with that one. But the key is, when you see these parentheses being multiplied, look at the exponents and just add them. If they're not the same denominator in the exponents, you're going to have to find common denominators before you add them. But that makes it a lot simpler. Okay, so that's it for 6.2.